In this video, we will talk about properties of ionic compounds. Ionic compounds are formed between metals and nonmetals. Um, we've been You've been looking at this periodic table that I draw like 25 times in every video. So I'm sure you yourself know how to draw the periodic table by now. So this part of the periodic table are metals, and the upper part of the periodic table is nonmetals. So to make an ionic compound, I need somebody from the metals and somebody from the nonmetals. So if I have sodium from the metals and I have chlorine from the nonmetals, so that sodium chlorine will make an ionic compound because it is a metal nonmetal combination. So metal nonmetal combination. If I have a calcium from here and oxygen from here, so that calcium and oxygen is a metal non-metal combination, and it will make an ionic compound. So it's a metal non-metal combination. Metals are positive ions or called cations. Non-metals are negative ions or called anions. Okay, electrons are transferred. Positive ions means what? Loss of electrons. Negative ions means what? Gain of electrons. So what happens is that sodium has one valence electron. Chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So what happens that sodium gives this electron to chlorine. Okay, so sodium lost an electron and chlorine gained an electron. So electron is transferred from the metal to the non-metal. Okay, so electrons are transferred for ionic compounds, and this formula that you make right here is called formula unit. Okay, we use the word formula unit. You see they have very specific crystal structure, that each positive is surrounded by the negatives and each negative is surrounded by the positives. Okay, and each positive, as I was saying, is surrounded by the negatives. So this is called very specific crystal structure. Okay, they repeat the pattern of positives and negatives. They have very strong bonds. They are solid at room temperature and they form crystals. Okay, they have high melting point and high boiling point because they have very strong bonds. They're good electrolytes. They conduct electricity when dissolved in water or when they're melted, but they're brittle solids. Okay, they're not soft. They're hard, brittle solids. Okay, they have high melting and boiling point. When they conduct, they're good conductors of electricity. They're electrolytes when you dissolve in water. They have repeated pattern of positive and negative, very strong bonds, solid at room temperature. They form crystals. Um, so which pair of the atoms would form an ionic bond? So I'm looking for ionic bond, I need a metal and a non-metal combination. So I know magnesium is a metal, okay, but sodium is also a metal. So a metal will not make us ionic bond. I need a metal and a non-metal. Okay, so this is a metal non-metal combination. These are both metals. Okay, this is a metal, this is a metal, this is a metal, and this is noble gas. Noble gases don't react. Okay, noble gases do not bond. So I cannot bond anybody from that group 18. Okay, which would form a cation. So cation is a positive ion that is formed by loss of electrons, and only metals do that. So I'm looking for a metal right here. This is a metal, it's a non-metal, this is a non-metal, and this is again noble gas. Noble gases neither lose or gain, so I don't even count this. Which would form an anion. Anion is a negative ion formed by gain of electrons. Okay, gain of electrons, and only non-metals do that. So francium is a metal, helium is a non-metal, but it's a noble gas, so I don't count that. Noble gases I don't count. Boron is a metalloid. Okay, it's a metalloid because it acts both metals and non-metals. So oxygen is a non-metal here. So these are the properties of ionic compounds.